Mm, Welcome, everyone. I am Don Rivera Diaz. Give me a moment here as I make sure that you have access to my voice, access to my screen, and everything is perfect. All right, everyone. I am so excited today to talk to you about today's presentation led by me, Don Rivera Diaz, for data-driven cybersecurity, specifically network intrusion detection using machine learning and big data analytics. This project on network intrusion detection using machine learning and big data analytics is a way for us to spot cyber attacks hidden in massive network traffic. I'll explain what I did, what I found, and how this can strengthen network security. Why did I choose this project? Well, because cyber attacks keep getting more and more advanced and harder to detect. I wanted to see how data science could help automate detection instead of relying only on traditional defenses. Using PySpark also let me test how big data tools can handle real-world traffic size efficiently. Firstly, when we have efficient practices, we have effective practices. I used CICIDS 2017 dataset. It's pretty much like a standard for testing intrusion detection systems. Studies show random forest often performs best, while isolation forest helps catch new, unseen attacks. So ideally, we would want to equip ourselves with both of these awesome tools. My goal is, for this project, was to test both approaches on large-scale network data. I want to give a quick shout out there. One of my awesome references, Rodriguez, 2012, 22. Check that out if you have an opportunity. The problem was clear. Detect malicious traffic hidden in millions of normal connections. There were challenges. Challenges included processing huge data, keeping false positives low, and spotting both known and unknown threats. I wanted to see which method handled these challenges best. I used Apache Spark with PySpark to clean and process millions of data points. Took a while, but it was worth it. Spark let me scale up easily and run tasks much faster than standard tools, so I do suggest it. This setup shows how intrusion detection can work at enterprise scale. I compared two models, random forest and isolation forest. Random forest is supervised. It learns from labeled attack data and gives really good accuracy. Isolation forest is unsupervised. It looks for anomalies, even if they've never been seen before. Pretty much, what's strange in here? What doesn't fit? Together, they cover both known and new attack types. I measured accuracy, precision, recall, F1 score, and ROC AUC, which is rock. Random Forest reached about 96% accuracy with strong recall and precision, while Isolation Forest scored around 88%, showing it's good for anomaly detection, but with more false alerts. So if you don't mind some false alerts, it's a really great opportunity. The results matched what other research has found. The ROC rock curve and confusion matrix show random forest outperforming isolation forest. The feature importance chart also highlights Which network features matter most? Overall, random forest gave the most reliable detection results. I love this part. Discussion. So think, synthesize, process. Random forests worked well for labeled data, while isolation forests helped catch new threats. In real systems, results can shift as data changes over time. Using Spark makes this approach practical for huge real-time datasets with millions of records. Now, main cybersecurity challenges are evolving attacks, data imbalance, and false positives. Data science challenges are labeling, scaling, and keeping model accuracy high. There are future improvements that I've noted, which could include ensemble methods and or I would prefer the and real-time streaming models. Hope that you are all learning a lot, taking a lot of notes. Ah, finally, combining, uniting PySpark and machine learning does create strong frameworks for detecting intrusions. Random forest handles known attacks best. Isolation forest adds flexibility for new ones. This project shows how data-driven methods can make cybersecurity faster, smarter, and, you guessed it, scalable. I want you to write that down. For me, it's been ingrained and it's part of my notes. Data-driven methods can make cybersecurity faster, smarter, scalable. Faster, smarter, scalable. Amazing. I want to share with you my awesome, awesome references here. And I really appreciated the chance to explore each and one of them. They're all amazing. If you have an opportunity, please check these out. These are my main sources. The CIDS 2017 dataset and key studies from cybersecurity research and Kaggle or Kaggle analyses. They guided the methods and helped validate all of my results. Thank you everyone for joining today. I am Don Rivera Diaz, and I hope to work with you in the future. If you have any questions, feel free to reach out to me. See you later.